Hello and welcome to Engineers Mindset Academy. Alright, so we've done the very first video on inverse Laplace transformation. Do well to watch that introduction video for proper understanding, because we are going to be using all the ideas shared in that video to solving this particular problem. Now let's consider this question on the board. The question says, find the inverse transform of the given function. So you're having Laplace inverse of 3x plus 1 all over x squared minus x minus 6. This is what we have to find. Now, of course, normally we cannot find the inverse transformation of this function. But the first thing to understand is this is a compound fraction. So if it's a compound fraction, then we can simply use the idea of partial fraction to break this compound fraction into bits. The first thing to do is, let's pull out the compound fraction. We have 3s plus 1 all over x squared minus s minus 6. So you look at the denominator, because the idea behind compound fraction or partial fraction is at the nature of the denominator. The nature of the denominator of every fraction determines how or what method you're going to be employing to solve the partial fraction or break down compound fraction into partial fractions. So the first thing is to look at the denominator and see if we can be able to break this denominator into what? Into factors. All right, so denominator is x squared minus s minus 6. So we look for a number or two numbers such that when we multiply these two numbers, we are going to be having what? Minus 6. And when we add these two numbers, we are going to be having 1 or minus x, as the case may be. Okay. Now, what are these two numbers? Notice that if I multiply plus 2 by minus 3, this will give me what? Minus 6, which is a constant. And then again, if I add plus 2 plus minus 3, this will actually give me 2 minus 3, which is actually minus 1. So which means the two numbers are plus 2 and minus 3. Hence, we can write this denominator to now be equal to x squared. In place of s, s becomes plus 2s minus 3s. Of course, 2s minus 3s will simply give me what? Minus s. So plus 2s minus 3s, of course, gives me minus s minus 6. Alright, so I'm using the idea of what? Factorization now to find the factors of the denominator. I'm using the idea of factorization now. Alright, so this is now equal to, we can simply factor these two and factor these two aside. Okay, so factoring these two, I have x squared plus 2s plus, keeping these two aside, then you factor this other two, minus 3s minus 6. You have something like this. Now, between s squared plus 2s, s is common between the two of them. So I can factor out s is out. I'm left with just one x here plus, if I pull out this s here, that means I'm left with only 2 here. Similarly, this is plus. Between 3x and minus 6, this is minus 3 and minus 6. Minus 3 is common between the two of them. So I can pull out minus 3, open a bracket, that means I'm left with only s here. If I'm removing minus 3 here, that means I'm going to be left with plus 2 over here. So if I rearrange this equation, notice that s plus 2 and s plus 2 are the same. These are common terms. So you pick one of the brackets that is common, you have s plus 2. Again, pick the terms outside the bracket. I have x and minus 3 outside the bracket. Pick them and form another bracket with them. So you have x minus 3. So which means x plus 2 times x minus 3 obviously will give us what? X squared minus s minus 6. Now let's try it and see. This is equal to x times x is x squared. X times minus 3 is minus 3s. Plus 2 times s is simply what? Plus 2s. Plus 2 times minus 3 will give us what? Minus 6. And this is now x squared minus 3s plus s will give us minus s minus 6. So we still have this. Hence, I've been able to break what? I've been able to now find the factor of the denominator to be what? S plus 2 into s minus 3. So that means this compound fraction can now be written as 3s plus 1 all over, in place of this denominator now we have s plus 2 multiplying s minus 3. Okay, so you have this. So that's the very first thing to do whenever you encounter a compound fraction. If you want to apply the principle of partial fraction to break them into bits, you have to consider the nature of the denominator first. If you can factor it like this, then you can solve. Now I have this by the idea of partial fraction. This is equivalent to, since I have two brackets under, it becomes a all over the first bracket s plus 2 plus b all over the second bracket s minus 3. We simply have something like this. All right, so I have now the whole of this, which is 3x plus 1 all over s plus 2 times x minus 3 is now equivalent to, I will consider the LCM of the right hand side now. So the LCM still remains s plus 2, okay, times x minus 3. This remains the LCM. Now the whole of this LCM divides s plus 2. S plus 2 cancels s plus 2, so I'm left with x minus 3. X minus 3 times a will simply give me a into s minus 3 plus, same thing, the LCM now divides x minus 3. X minus 3 cancels x minus 3. I am left with s plus 2. So s plus 2 times b, this becomes b times s plus 2. Okay, b times s plus 2. I have this. Now from the idea of partial fraction, since the denominators are equivalent, it also means that the numerators must be equivalent. Since denominators are equivalent, the numerators must be equivalent. So this simply implies I'm now going to be equating the numerators. 3s plus 1, I have 3s plus 1 to now be equal to a times x minus 3 plus b times s plus 2. All right, so we simply have this. Since denominators are the same, it means their numerators must be what? The same. All right, now if I have this, I need to find the values of a and the values of b by a very simple shortcut. In order to find a, I will need to make b 0. But how do I make b 0? Which means I need to find a value of s that will nullify the effect of b from this equation. I have b times x plus 2. That means if x is minus 2, I will have the minus 2 plus 2. Hence, it becomes 0. b times 0 becomes 0. Therefore, I can only find the value of a. So, in order to find a, you consider the value of s to be what? Minus 2. That will cause b to automatically what? Become 0 here. Alright. So, you say let s be equal to minus 2 to find a. So, wherever you see s, put in the value as minus 2. This now implies that I have 3s here. This becomes 3 times, in place of s is minus 2 plus 1. And this is equal to a times s here becomes what? Minus 2 minus 3 plus b into s is now minus 2 plus 2. You have this. 3 times minus 2 is minus 6 plus 1 is now equivalent to minus 2 minus 3 is minus 5 times a plus b into minus 2 plus 2 is 0. So we have seen now that the effect of b have been nullified. B times 0 becomes 0. So I have there minus 6 plus 1 is minus 5, being equivalent to minus 5a. Of course, the effect of b times 0 becomes 0. Therefore, I can find a to be equal to minus 5 divided by minus 5, which implies that a is equal to what? 1 from here. Of course, dividing both sides by minus 5, I will have it to be equal to 1. That is the first thing. From this same equation, to find b now, you look for a value of x that will make the effect of a 0. If this is x minus 3, that means if I call x 3, it becomes 3 minus 3, and hence I will have what? 0. This effect of a becomes what? 0. Then I can find the value of b. So to find b, set s to be equal to what? X minus 3. Let's do that over here. To find b, set s to be equal to what? 3. You set s to be equal to 3. Then let's plug it now into this equation. This is 3x plus 1. You have 3. S now is 3 plus 1 being equivalent to a into, I have here s minus 3. And s now is 3. This becomes 3 minus 3 plus b into, I have here x minus s plus 2 for b. Now s is now 3. So this becomes 3 plus 2. Alright, so 3 times 3 is 9. 9 plus 1 is now equivalent to a into 3 minus 3 is 0. Again, the effect of a have been nullified. Plus b into 3 plus 2 is 5. You have something like this. So 9 plus 1 is 10. 10 is now equivalent to 8 times 0 is gone 0. B times 5 gives us 5b. Therefore, to find b, divide through by what? 5. You have b to be equal to 10 all over 5, which implies that b is equal to 2. So we have the value of b to be 2. Now we know a, we know b, we cannot plug into this equation. Now this is now equal to a is 1. That means you have this to be what? 1 all over s plus 2. Then b is 2. So you have this to be what? 2. This is plus 2 all over s minus 3. So we have been able to break this compound fraction into two simple fractions. We can now find the Laplace inverse. Hence, the Laplace inverse of the compound fraction 3s plus 1 all over x squared minus s minus 6 is simply equal to what? The Laplace inverse of their simple fractions or their partial fractions, which is 1 all over s plus 2, okay, plus 2 all over s minus 3. You have something like this. Now, if you have this, then you can now find what? If you expand the brackets with this Laplace inverse, this is actually what's going to be Laplace inverse of the first term, 1 all over s plus 2, okay, plus the Laplace inverse of the second term, 2 all over s minus 3. You have this. Now, you know, in the table of standard values, which we've talked about earlier, we said that the Laplace transformation of an exponential function, if you recall, exponential at, we said the Laplace transformation of an exponential function, say exponential at, is simply equal to 1 all over s minus a. We said this in the 3 introduction video we did concerning table of standard values in Laplace transformation. So it is something you need to know. The Laplace transformation of an exponential function is given as 1 all over s minus the number attached to that function. So, and I said also, this means if you're asked to find the Laplace inverse of 1 all over s minus a, automatically this is what? Exponential at. It's as simple as this. Now, I am seeing 1 over s plus 2. So, which means the Laplace transformation of an exponential function raised to a minus number, let's say Laplace of exponential minus at, if when it is positive, it gives us negative value here, that means this will give us what? 1 all over a s plus a. You will have it to be positive, because the Laplace of an exponential function when it is positive gave us what? S minus a. Now, if it is Laplace of minus at, it becomes what? 1 all over s plus a. So you keep this in mind. Now, having this in mind, I am seeing 1 over s plus 2. I'm also seeing 2 all over x minus 3. So which means I can factor these two out. Okay, I can factor these two out. Let's continue over here now. Okay, so this is now Laplace inverse of what? 1 all over s plus 2. All right, plus 2 is now factorable. If I bring out 2, this becomes 2 times Laplace inverse. I have now 1 all over s minus 3. So with this, it becomes very clear. With this, it becomes very clear from what we've been explaining from the table of standard values in Laplace transformation. So do well to watch all the videos to properly understand everything. We've done 3 videos on introduction to Laplace transformation talking about the table of standard values. So all of this was explained there. Now I have this. The Laplace of, or Laplace inverse of 1 all over s minus 3, I'm seeing there 1 all over x minus 3 automatically becomes exponential to the power of 3t, because we said Laplace transformation of, we said the Laplace transformation of exponential at will give us 1 all over s minus a. We said this in those videos. Laplace of exponential at will simply be 1 over x minus a. Now I'm saying 1 over x minus 3, where a stands for what? The number. That means this is simply what? Exponential. In place of exponential at, it becomes exponential 3t, where 3 becomes or represents a. So this is when it is what? When the power is positive. Hence, in this case, I'm having Laplace of s plus 2. That means this is Laplace of exponential minus at, Now, when the power becomes negative, then the sign will change here. Since it's still exponential function, it becomes 1 all over s minus a. So which is now equal to 1 all over, because it's supposed to be x minus a, where a stands for the number. In this case now, a, which is number, is minus a. You have minus a. Minus becomes plus. You have x plus a. So this simply means that the Laplace transformation or Laplace inverse of 1 over s plus 2 is automatically exponential minus 2t. Keep this in mind. So, which means this becomes what? This is now equal to the Laplace of 1 over s plus 2 is simply what? Exponential minus 2t. We have exponential minus 2t plus the Laplace of 1 all over s minus 3 gave us exponential 3t. But not forgetting, there is 2 multiplying it. This becomes 2 exponential minus exponential 3t. So, this is the answer to that given question. That's how you solve Laplace inverse of a given function. I will see you in the next video with more problem on Laplace inverse. Thanks and cheers.